another use of differentials is to estimate functions that are complicated, okay? Computers do this all the time. They use slightly more sophisticated versions of what we are doing. Well, quite sophisticated versions. But what we need to do here to use the differential is to recognize that there is a function that is the cubic root of x. And here what I have is actually f of 28. And then the differential, the way it works, so this f of x is my y. Okay, the way the differential works is computing the difference in the output based on the difference in the input. So this is the difference in the input, and this x here is the point around which I'm working. Okay, so here the key is, I don't know you, but doing the cubic root by hand, it's not an option. Okay, we would need a calculator. What I'm going to show you is something that you can do without the calculator. So how do? We will need to approximate using some value. We need to find some value x such that the cubic root of x is easy. Okay. So my suggestion, 28, it looks like the closest perfect cube is going to be 27. Because that's 3 to the power 3, which is the closest perfect cube. We can use any number, but the farther we are from 28, so we need to strike a balance. We need to find some number that is useful, that is easy, a perfect cube in this case. But we need something that is close, because if it's not close, then we are going to be very off. Okay, so we are going to apply this derivative at x equals 27. And then the dx is going to be the increment, which is 28 minus 27. Okay, so I need to compute the derivative. So f prime of x is, because this is x to the 1/3, the derivative is 1/3 x to the negative 2/3. Okay, so let's continue here. So this is going to be 1/3 times 27 to the negative 2/3 times 1. Okay, 1 is 28 minus 27. So this is 3 to the power 3 to the negative 2/3. So there is a cancellation. I'm taking the cubic root of a cube. So this is 3 to the negative 2, that is 1/9. Okay, so here I get 1/27. This is actually by chance. And when I compute the exact value, well, I get an approximation 0.037. Okay, so this is the difference in output based on my difference in input of 1 unit. So if I want to estimate f of 28, that is going to be f of 27 plus the difference in output, sorry. Okay, this dy approximates the difference between f at 28 and f at 27. So f of 27 is the cubic root of 27, and then plus 0.037. So this is 3.037 approximately. Okay. You saw here that I had to divide 1/27, but that was it. Okay, if we compute the actual value, okay, f of 28, that is the cubic root of 28, and I challenge you to do this without the calculator. There is a way to do it, but it's very complicated. But we get this 3.0366. Okay, so we see that actually the first two decimal digits are correct. And then the approximation of the third is also good. Okay, because if we round to the third digit, it's going to be the same, 3.037.